Hello, welcome to another video about Reflexis Flow. This is the third video in our writing parts series, and today I'd like to do things a bit differently. In the previous two videos you saw me creating a part from scratch for one of our current projects. So they were basically two live coding sessions, and for this third video I think it's a good idea to start off with a recap and provide you with a summary of all the things we discussed previously, and in the second half I'd like to talk about all the things that we did not yet discuss, and hopefully that'll give you a good overview of all the things you need to know when you want to write or start writing your own parts. So I've written up some notes, and so I don't forget and skip some important bit. And let's take it from the top. What are parts? Just very briefly, for us, parts are pretty much the building blocks of web applications. So in the view of our platform, any page that an end user sees, or any action that should happen on the server is a step. We've just named them steps. So browser pages are created by steps, and any action that happens on the server is also created on a step. And we call so we divide them up into user steps or browser page steps, and silent steps or server steps. And to do something, to show something in a page, or to do something on the server, you need to plug parts into these steps. So for instance, if you have a basic form that a user should fill out, you can add page elements, parts, to this particular step, and have input fields and buttons and whatnot. And the same thing obviously goes for server steps, where you want to perform a query or send an email or whatever. So again, parts are the building blocks of our web applications. So why would you want to write your own parts? I think the answer is fairly simple. Creating your own building blocks allows you to do stuff your own way. We do provide a toolbox of what we call standard parts, and obviously these can be very useful, but they can also be very limiting, because maybe you have a better idea of how to do things. Maybe there's something special you want to happen in a browser that we did not think about or didn't care about, but you do. And by writing your own parts, you can really mold the platform to your own desires and to your own wishes. So I would really encourage anyone to come up with their own parts and do stuff their own way, because that's probably the only way to really make things, to optimize things and make them happen the way you want them to happen. So with that out of the way, parts can basically be divided into interactive parts and server parts. So an interactive part is a part that you plug into a page that the user sees, and doesn't mean that it has to be something that every interactive part is something you know, something visible in the page, but it's something that contributes to the page. And obviously a server part is you know, stuff like performing queries and, like I said, sending emails, and anything that manipulates data on the back end can be a server part. And there's a subtle difference that you'll see in a second about how these different parts should be designed. So it's good to know about flow phases. Like I said, web applications for us are a collection of steps, and these steps represent, you know, application states or you know, a particular page that the user sees. And during the lifetime of a step, there's a particular cycle that's going on. And cycles are the compose, the present, the respond, and the processing phase. I'm not going to discuss the compose phase because it's not very relevant for our discussion. But it's good to know that the present phase is the phase where the page is produced. And when the present phase is complete, it's being sent to the browser, and the end user can interact with it. So the respond phase is anything that happens on the page and happens in the background, happens what we call asynchronously. So the page remains in the browser, but stuff can still happen, and all this asynchronous in the background interaction is handled in the respond phase. The processing phase is the phase where all the output, all the input is being collected and sent back to the server, and parts can then, you know, finish what they've started during the present phase, and maybe change states. So in our terminology, it would mean that if a step is being processed successfully, it'll move on to the next step, or, you know, another step. So this is all pretty basic stuff if you've already worked with Reflexis Flow, but it's still important to be aware of. So how are parts structured? Parts are pretty much, you know, small Lua scripts. And basically they're scripts that return a table that holds their methods. And we'll get to the methods in a second. But they're basically small Lua scripts, or not so small Lua scripts. You can make them as complex or as simple as you'd like. Most of our parts are fairly basic because we'd like to keep things simple, but you can do pretty much anything you want. And these scripts, they reside in a particular location. If you have a flow instance, then they're placed underneath the libtask folder, somewhere underneath. Okay, like I said, a part is basically a little component that represented as a Lua table with methods. These are the standard part methods. Like there's a present method for presenting the part, a process method for handling all the input that the user provided. There's an execute method. Execute method is something that we did not discuss in the previous two videos, but execute methods are basically the method that you use for server parts, but because for server parts, like, you know, again, when you want to run a query or do something else, there's no presenting and processing going on because there's no page that has been produced. There's just an action being performed on the server, and for these parts, you provide an execute method. So the respond method is something that should look familiar in the validate method is something that's not being used runtime, but it's being used model time, when you're designing your flow. And validate methods can help you do custom validation. So the standard flow validation mechanism performs all sorts of checks, like if a part has required properties, are these properties provided? If targets are being set, if gates are connected, do they go anywhere? Stuff like that. Is there a starting step? Are all steps actually reachable? Stuff like that. But using part validate method allows you to do much more complex checks for your flow. Anyways, all these methods have pretty much the same signature, and these should look familiar. And if you've seen the previous two videos, and you really should, if this is the first video that you're watching, stop right now. Look at the first two videos first, and then come back for this summary. But again, the present method, the process method, the execute method, they all have these 4 arguments. So for the validate method, there's no phase method, but the 4th argument is the register function that you can use to signal back any errors. Naming, well, naming is always a tricky thing, I think, but it really helps to come up with good names, especially for parts, and even more so for properties. We started out using a subfolder structure, so many of our user interface elements went into the UI / whatever category. All the other stuff we put in, standard / whatever. We came up, and having good names really helps, because like I said, the parts are your building blocks, and giving them good names will help you in the long run a lot. And obviously the same holds true for properties. Okay. When you write parts, obviously the part properties control the behavior of your part, of your component. So you need to be able to read them just as much as you need to be able to access any incoming data, any incoming variables. So what I've shown you is that using the self argument, so this self argument is actually the argument of the function signature. So under self you can access all the part properties. Similarly, so this CTX is the CTX here. CTX vars holds all the incoming data. So you can use those to read both the properties and any incoming variables. And obviously, sometimes you need to know more. So any session has a data space associated with it. We call it the session context, and you can put pretty much anything. Well, not anything, but you can put a lot of information in the session context, and you can do that using the get and the set functions. So get allows you to read data from the context, and set allows you to put stuff back in. Sometimes data need not be so persistent. So anything you put into the session context will stay there until you remove it. So that's one of the reasons why you need to manage your context. Don't go plugging stuff in like there's no tomorrow, because the session context needs to be read. from file for every request that Flow handles. So you need to make sure that your session context is small, and doesn't grow too much. Having said that, some data is just temporary, and for instance, in the previous two sessions, the editor that I wrote found during processing, during handling of all the user input, it could find that stuff was wrong. So you need to remember that for when the part re-renders itself, because you want to put in a little indicator to signal to the user that something was wrong and you cannot accept this particular input. So to remember that, you could plug stuff into the context, but then you would need to manage that. And this becomes a big chore, and if you find it too much of a chore, you may forget to manage it, and your context will just grow and grow and grow and grow. And to ease that, we came up with a scratch pad mechanism. So there are actually two tables: the my pad table and the trail pad table, tpad, and these are really convenient for managing any temporary data. So these tables are private to your part, and they will exist for as long as the part exists. So as soon as your flow steps away from moves away from the current step, the scratch pads are wiped. And like I said, because they're private to the parts, there's no interference between parts. So anything that one part plugs into its own MyPad, for instance, cannot be read by any of the other parts. So this isolation really helps to keep things, secure and safe and whatnot. So what's the difference between MyPad and TrailPad? Because I did not discuss TrailPads in the previous two videos. MyPad is cleared as soon as flow moves to another step. A TrailPad stays alive for as long as the request is being handled. So for us, trail means a sequence of server steps, and this is something that, for instance, we often use for creating reports. When you chain server steps together, you can create loops, you can create nested loops, you can do a lot of stuff very easily, especially using, for instance, the iterator parts that we provide. And sometimes you want parts in such a subflow trail to keep data, to manage their own data private. And so the TrailPad, the tpad, can really help with that. Okay, moving on. This is another thing that we did not discuss in the previous two videos. This has to do with, we did discuss the error member. So ctx.error can be used to signal to Flow that something is wrong. This is something that I did when, for instance, we detected that a user typed a non-number into a number field. And if that happens, you don't want Flow to move away from your step, but to hang around there and to retry this particular form. And so setting error is a way for a part to let Flow know about this, know about the error. However, in this particular case, So in the case of the editor with the faulty input, if there was faulty input but the user would have pressed the cancel button, you also need to have a mechanism that the editor could not prevent the flow from stepping away. So the ignore errors member of CTX stands for context, and again it's the first argument of the process method. So this all obviously happens during processing. Ignore errors can be, if you set it to true, it's basically a signal to flow, okay, if there are any errors, don't worry about them, you can still move on. And this is something that a cancel button would typically do. And finally, ctx.target can be used to perform routing. And obviously routing is something that a cancel button will also do. So assigning something to ctx.target means, basically tells Flow, choose this particular gate if you decide to move away from this step. Things are as easy as that. By convention, if you look at the base parts that we provide, there's a convention that if CTX target is already set, other parts do not touch it anymore. So then the convention is, so the first part that sets the target gate is basically in control, and you have a rule that allows you to reason about how routing is performed. But this is by convention, it's not something that is enforced by us. Right. Something that we talked about as well is, how can you style? Excuse me. How can you enable a flexible styling for your user interface parts? And like I've shown in the previous videos, it's mostly a matter of providing the right structure and using that structure to add classes, so you can namespace stuff, and you can easily link the right CSS to this particular output of your part. And it's pretty much as easy as that, but it's something that you do need to think about. And again, here it helps to go by convention, come up with a good scheme, and then stick to it. So one of the things that we did for our base part is to have a bit of a one-on-one relation between the part name and the class name that's being used for this part. So most of the time you don't need to remember which class is being used for which part. So and during the live coding sessions, the part was called RM editor, and that was the class that I came up with to provide the CSS. As soon as your part creates page elements, it also becomes important to give these elements, consistent IDs and IDs that do not clash. And again, we don't enforce anything, but we came up with the convention that works really well. So if part X, generates something that ends up in the page, we usually give it the ID X. And because parts need to be uniquely named in each step, using this scheme, you already know that you cannot have any ID conflicts with all the elements that they generate. So sometimes, obviously, a part creates a more complex structure, like the editor part that we created earlier. And it's a good idea to use underscores, 2 underscores, not 1 but 2 underscores for any derived elements. Why 2? Because Flow enforces that you cannot use 2 underscores in any part names. We're not really very strict, but the Flow modeler does enforce it. If you try to name a part and use 2 underscores as a name, it'll flag it, and you need to come up with a different name. And this is pretty much to safeguard this naming scheme. Modeler support. That's something that I think we ended with, I think, in the second session. Info sections provide information, introspection to the modeling environment about what your part can do. So what we saw is that the info section can hold a description for your part, and it can hold a section called fields to describe the properties. Well, maybe we should have called it properties, but we came up with the name fields. And obviously fields are, again, tables, as you saw, describing by name and type and, whatnot. What the property is all about and what it does. I think I forgot to add the help field. The help field for each, the help key for each field describes what the property does, and that's something I forgot during the live coding session, but it's something that you can find in all of the base parts, so study them, and because they all tackle some sort of problem in hopefully a sensible way, and just by studying the sources of all the existing parts, there's a lot of stuff that you can find out easily for yourself. But, again, info sections are important because they help others to use your part, and they also help the platform to validate your flow, and they help check if your part is used correctly in your flow. So be sure to add them, and because it really helps. We talked about security. I came up with a little demonstration of cross-site scripting. And hopefully it's something that you will always keep in mind. The rule that you should never forget is this one. You should never trust the data that you receive. Always assume that things are not right, and validate. Make sure to check, whatever it is that you expect to be coming in. Never assume that it is what you expect. Just make sure that it's valid, and that's really the only rule that you really need to remember. Unfortunately, it's something that's so easily broken, as I hope I've demonstrated. There are so many ways to go wrong here, and actually I came up with a second rule. You should never leak any information that you don't want to leak. So for instance here, I said, don't. So if for instance you do a query and there are some records that you came up with, and you show these this result, as a list to the user, and the user can choose one of these items. you know, it's so easy to think, okay, to identify any of these items, you know, let's use the original record IDs. But as soon as you decide to do that, and these record IDs end up in the page, you're basically saying these record IDs is something that that I want to act on once the user makes a selection. So if you plug them into the page and you think there's a good reason for that, usually the answer is, usually the reason is that you expect to receive one of these IDs back and you know, perform some follow-up action on that. But how do you know that any ID that comes back is actually one of the IDs that you plugged into the page? Maybe it was a different ID of a, you know, of a record that you really did not want the user to see. So hopefully this is something to think about. As soon as you leak unnecessary information, you're usually about to break the first rule and forget to check that any of the IDs is actually one of the IDs that you sent out, that you put in the page yourself. Anyways, cross-site scripting is something that I mentioned. So Unicode or UTF-8 is something that you need to be aware of. All our flow runs in UTF-8. Everything operates in UTF-8, which is really nice. In the past, you needed to make sure that any Unicode or UTF-8 that came in was validated as well, because you can actually use invalid encodings to bypass all kinds of checks. And in the past we said, okay, all the parts need to do their own input validation for UTF-8. And but that's something that you don't need to do anymore. We made it a standard mechanism. All the variables that come in is always checked by Flow itself before it is being passed on to the parts themselves. So anything that you read from here, from the vars table here, will already be at least validated using the UTF-8 len function. But you still might want to do the trimming yourself, because we don't do trimming by default. That's something that part might decide to do. So this part is handled fairly standard, you know, by default by Flow itself. But this part, you know, is something that you need to think about yourself. And again, this goes back to my little demo. Any input that you receive, you need to make sure that it's okay, and because a lot of input that you pick up and store and reuse later may contain things that you don't want to be there. So there are all kinds of strategies that you can use to prevent this from happening. So, and I discussed it, that you can try and detect stuff, but that may be fairly tricky. But because there's all kinds of ways to, you know, people can come up with all kinds of variations, and you need to be sure that you deal with all the variations in your detection, during your detection. So we found that a good way to sanitize input is simply to escape it, and that's something that I've demonstrated as well. Excuse me. So we provide functions in this library script, the escape HTML function that I showed you earlier, and you can use escape HTML and unescape HTML to escape or unescape any data that you need to deal with. But again, you need to decide on when to escape stuff. Well, do you escape stuff while you present output, or do you escape stuff when you process input? And like I said earlier, usually our team uses escaping during processing. And the reason for that is that you only need to do it once, and whoever picks up any of the data that's already being escaped when it's received, when it comes in, the data is already sanitized. So you don't need to be you don't need to check and double check and triple check that every consumer of this unsanitized data actually does the escaping itself, because has already been escaped. So we find it's more convenient and more optimal to sanitize texts as they're coming in. All right, I think that kind of concludes all the stuff, or most of the stuff that you saw earlier. So let's move on to stuff that we did not yet talk about so much. And so I think the biggest topic here is the synchronous versus asynchronous behavior. Asynchronous behavior, we call it asynchronous because a long time ago they called anything that happened in the background asynchronous operation. There was this term AJAX, and which used the A of AJAX stands for asynchronous, and so we basically said, okay, let's call this anything that happens in the background while the page is still there, asynchronous, and anything that happens while the form is being submitted, while the page is being refreshed, let's call that synchronous. And during the live coding session, we pretty much focus on synchronous operations. So the editor part had a present method, it had a process method, and it also had a respond method, but it did not do that much during the respond method. And it's good to know that you can pretty much have your part do anything you like asynchronously. And it's what I'd like to do here is talk a bit about how you can make that happen. So if you want your part to respond asynchronously, you need to advertise to Flow. You need to say to Flow, okay, I can react to I want to respond to particular verbs. Like, so in the editor example, we only connected to the refresh verb. The refresh verb is something that basically says, okay, re-render yourself. Something changed, some of the underlying data, for instance, in the session context or in the database or whatever changed, and update yourself, and and that's it. But a part can pretty much connect to any verb that you come up with itself. So So you don't need to connect to a refresh verb. You can connect to an update verb or a select verb or a delete verb. You know, verbs are basically little strings that you come up with, and you can have as many verbs as you like, as long as you provide a respond method that deals with them. So the guarantee is that if you don't connect to a verb, that verb will never be, your respond method will never be called for that verb. But if you do connect to a verb and the page sends this verb to the backend, so the front end sends this verb to the backend using a simple post mechanism that I'll show you in a couple of minutes. This verb and any data that's attached to the verb, any arguments, will arrive in the respond method, and the respond method can then act accordingly. So what is it that a respond method can do? Well, in our example, you know, for the refreshing example, it was just a matter of printing ourselves anew. So that's one of the things you can do. You can print stuff, but what happens with anything that you print? The output that you print will be sent back to the page, and the page will find the container. It's what we call a container. The container element for your part, and replace anything that you print. Put anything you print in the container and replace the original contents. So essentially, there are. If you look at printing, there are basically three scenarios. You might not want to do any printing, so if no output is printed, then your part will remain the same in the page. Nothing will be refreshed. The container will still, hold the original content. If you do print stuff like print HTML or print script in a script element, obviously, then it will replace the original container. So the HTML will go into the original container, and the script will be executed afterwards. So the third scenario is that, for instance, your part decides that it should go dark, it should go invisible, and it wants to hide itself, and then it needs to replace its original content with something else. And a simple trick to do that is simply to print a comment tag, and basically print anything that's not empty but won't show up as something that won't show up in the page itself. So comment, it's usually we print something like this empty, because this is a little comment. The JavaScript on the front end side will see, okay, I need to replace the original content of this part with this, but obviously there's nothing visible here, and this is a quick way to hide this part. What I did show you as well is Flow needs to be able to locate a part. So if your part is called XYZ, its container needs to be called cdiff XYZ, cdiff_XYZ. And if your part is called editor, obviously, it needs to be this. So that's how containers of parts are identified, and that's how they're located. And it also means that if you want your part to be able to respond to, for instance, a refresh verb, you need to make sure that this container is there. So during the presenting phase, you need to print it and put all the contents of your part inside this particular container. So the name or the ID needs to start with cdiff, but it doesn't need to be a diff. It could be a span or some other element, as long as it has the correct ID, so it can be located. So if you've been building stuff with Flow, then you know that one part, once it responds asynchronously, can actually trigger, it can kick other parts into action. And we call that triggering other parts. So, and there's a trigger function that you can use to kick the associates. So associates is the property that we always use for to indicate, to model all the dependent parts. And trigger is so that's the part property, and trigger is the function that you can use to basically kick them. Trigger actually has a signature that I'll show you in a minute or two. And the signature trigger, actually, you can actually say trigger this part using this verb and these arguments. So there are basically 3 arguments: the name of the part, the verb, and any associated data. If you leave out the verb, it'll assume that you're doing a refresh, because it's the most common verb, and this works really well. There's a shortcut, the star shortcut. If you study the base part, you can see all this. The shortcut is basically trigger star. So this is a shortcut. This means trigger all my associates. So you don't need to loop over the associates and trigger them one by one. That would be really awful. It's something that we used to do, many years ago, until we realized that this is a bit of a hassle. So trigger star is a shortcut notation for kick all my associate parts and tell them to refresh. Right. Subcontainers. Sometimes parts are not so simple. By that I mean, if you have a part that comes up with lots of different page elements, various sections in the page, but you created all these sections using a single part. What you don't want to happen is during, for instance, a respond, or during a particular asynchronous action. You don't want to have to redraw all the various bits and pieces. Sometimes when something happens in one section of your part, you only need to update a particular other section, or that particular section. And to do this, we came up with a simple subcontainer mechanism that you can print to. So, like I said, the main container of a part. This is something that you saw in the previous live coding sessions. The main container of the part is identified using this, where part is the name of the part in that particular step of your particular flow. So subcontainers are identified using this scheme. So again, there are This is an important bit, the two underscores that I talked about earlier. And this bit here is something that you can name, any way you like. But this basically means I am a subcontainer of this particular part. And if you, like I said, if you want to update the entire part, you can just print. And anything that you print will replace everything. If you just want a subcontainer to be refreshed, you don't use print but print s. So the s is for subcontainer. And while the basic print function is just like print anything you like, print s basically says, okay, name the subcontainer and then print anything you like. And that's pretty much all there is to it. This is a mechanism that we created over 10 years ago, and we really don't use it much, but it can be really, really handy, and it's something that you should look into if you ever decide to create more complex parts. Okay. Obviously, we've been looking at stuff from the server side, all the parts, the steps, the flows are present on the server, and all the parts run on the server. But obviously, in asynchronous scenarios, you need the page to send, to ping your flow, to ping your parts, and tell it, something's happening. The user is selecting something, or stuff is being done. The user is typing something and is pausing. So this might be a good moment to pass on the information in the background asynchronously, and have that part do something with the output that the user typed so far. And so to do that, we created a little JavaScript library. It's called flow2.js, and it holds a small set of helper functions that you can use to communicate with your flow from the page. So this JavaScript, all the functions in this JavaScript library are put in a namespace. It's so the namespace is RFX. That's the table that holds all the JavaScript functions, and your parts have access to the NS variable that holds this little string. So don't hardwire this string into your parts, but use the NS variable to know about the namespace of all the methods. So like I said, there are all these JavaScript helpers to enable you to communicate and do stuff in the page, and I came up with I came up with a little list that we'll look into in a second, so you know what functions there are. It's actually a fairly small set. Well, let's look at them now. So this is pretty much the list of public functions. There's a lot of other stuff in this JavaScript library, but all the other stuff are pretty much helper functions to these helper functions. So don't use those. Use only these public functions that. So these are the generic helpers, and I've categorized them a bit so we can quickly go through them. If you look at the JavaScript itself, the Flow2 JavaScript, you'll find that there's loads more, but these are mostly or either support stuff or stuff that's needed by the base parts. So stay away from those functions but you can use these. So what functions are there? You know, again, this is a really small list, so let's go through it quickly. There's a function to fetch an element from the page based on its ID. There's a function to get to the flow form. I don't see actually why you would need this, but you know, it's there. And there's an after load helper that you can pass a function to. So it basically says, okay, when the page is loaded, run this function. That's why it's called after load. So there's some basic class helper functions. You know, you can check if an element has a particular class. You can add a class, remove a class, toggle a class. So toggle will remove a class if it's already present, or just add it if it's not present. This can be really useful to toggle visibility, or you know anything that you care to think of. Set class is something that I think we only added very recently. I think this year, so that's something that may not be. I'm not sure if it. I don't think it was part of the last release, the last patch release that we put out. I'm not sure, but we actually found that it wasn't there. So that was kind of odd, but so we added it. There are some basic form manipulation helpers. Well, they speak for themselves, I think. A form has a particular number of inputs or variables, well, you can get them, set them. Set focus will set the focus to a particular form element. Init focus is something that calls set focus once it has figured out what it wants to focus on. And there's the init page function that actually does several things, like it prepares the form, it makes sure that all the functions that have been registered using after load, this one here, will be run, and it'll also call the init focus function. So, and the communication helpers are the ones that you might be most interested in. The step function is the function that's called to submit the form. So basically to instruct Flow, okay, let's try to move away from this step and move on. So it's essentially a form submit, and it has a couple of parameters. We found it useful to set a particular variable to a particular value. So you can do that, but you don't need to do that. You can leave them empty. These are fairly new, but new is relative, I think. During the demo, you actually, during the not the demo, but my live coding thing, you actually saw the reset functionality in action. You know, at some point I was clicking the cancel button, and any of the text that I had typed was not being submitted, and that was because the cancel button would have done a step with this set to true, so that reset the form, and that made all my input disappear, and had me puzzled for a while. Anyways, So step is the function that you use in synchronous scenarios. And send is the function that you use to kick a part. So you name the part, you mention the verb, and you provide any other data that you want to provide. So for instance, a data grid, or a menu list. If it acts asynchronously, it would use this function to send a select verb, for instance, and to provide the position of the element, so the index of the element that's being selected, to the part. And so any call to this function will eventually make the part with this name respond and receive this verb and receive this data. And that's all there is to it. So about this data, so this data here is positional, so it's like the first argument, the second argument, the third argument, and to make things a bit more safe or a bit more consistent, we came up with a mechanism where you first need to register the names of these arguments. So if, for instance, like I said, if you have a selection and you send a select part, send a select verb with, the 10th item is being selected, then you need to name that first argument and call it, for instance, index. So the register function is the function that you can use to say, okay, this part for the select verb has names, uses these names for its various arguments. And that's pretty much all there is to it. And that pretty much concludes our quick overview of the JavaScript part of Flow. Again, as you can see, this is all really basic. This JavaScript is, we haven't really touched this bit of Flow, for ages, because it turned out to be a fairly flexible mechanism. At some point we thought it might be good to split up these actual generic helpers and put the JavaScript for all the base parts in a separate library, but we never gotten around to it, and there's no real downside to the way we've done things at the moment. So. But obviously I'd suggest if you create your own parts to put all the JavaScript that they need into your own JavaScript file, and to make sure that your JavaScript file is included in the page. You can use the include function in your part. So if you look at parts that can act asynchronously, again, you can use the connect function to advertise to Flow all the verbs that you want to respond to. You need to add a respond method to define all the behavior for all the particular verbs. In this respond method, you can use the trigger function or trigger star to trigger any associates if you want to do that. And obviously, if in the respond method you print stuff, anything you print will act as a replacement for the container that you should have printed into the page for your part. And again, if your part is more complex and there are little bits and pieces that you want to update without touching any of the other stuff, you can use the print s function to print to subcontainers that use this naming scheme. So, and the s variable holds actually it holds this string, but please use this variable to know about the string. Don't hardwire the namespace into all your parts. I thought it would be a good idea to do a quick overview of everything that your part code can access, and to show you, I've come up with this overview. So again, like part properties, its properties is something, are basically values in the self table. And there was this CTX or context table that holds a lot of the other stuff. So these are the things that that your part can read. So CTX vars holds all the incoming data, all the information that's being submitted, either for processing or for asynchronous, responding. Nvars is a table that you can use to access environment variables. I don't think that's very useful, but if you do need to access them, this is the way to go about it. Language is something that's very useful. It holds the code that indicates the language or locale that your flow runs in. This is something that you usually need to pass on to, for instance, other library functions, like if you want to render a date and your flow is running, in English or in German or in Dutch. This is the way that you can find out which locale is being used, and you can pass that on to, this date rendering function. CTX phase, well, it's probably not very useful. I don't think any of these are really that important, but I've basically written them down for completeness sake. There aren't many occasions where you need to know about the session ID or the session key, the page key, but they're there. And during processing, these are the three variables that you can set, that you can write to. So target is something to indicate the gate that you want flow to use to move to the next step. Error is something to signal to flow that something was wrong, and you can use it to try to prevent any flow stepping. And ignore errors does the opposite. It basically says, okay, if anyone tells you that there were any errors, ignore them. You can move away. And this is usually, like I said, being used by things like cancel button and, all sorts of navigational elements that really need to move away, even though other parts might moan and groan about stuff that's missing. So these are all things that you can access using the CTX argument of all your part methods. And this is a list of all the primitives that are part of the environment, the global environment, so the global environment that your part runs in. So these should look familiar. The get method, you can use this to read from your context or to read from another conduit. Set method does the reverse, but for writing. Eval is, well, this is maybe a topic for a different video. Eval is pretty much, it used to be very different from get, but these days it's nearly identical. But you'll find that many of our old parts still use eval, even though probably they shouldn't. There's a very subtle difference where eval has access to the context, but also to some of the other global functions that that are available to you. This is something that you really need to be careful with. So if when in doubt, simply use get and set and stay away from eval. So print, well, we don't need to discuss print anymore, I think. Print you can use during in the present method and the respond method, obviously not in the process method. And print s is only available during respond, but because it allows you to update little subcontainers that may be part of your part. The connect function, you can connect to different verbs, and you can connect to as many verbs or no verbs as much as you like. Include, you can call include during the present phase, and it basically tells Flow, okay, include this CSS file or include this JavaScript file, and it actually instructs Flow to update the page header and add these CSS files and JavaScript files to the include section. Trigger here, this is the actual signature of the trigger function. You don't see this used much. You see this trigger star stuff a lot of times in our base parts. But like I said, it's actually more flexible than that. You can address particular parts. You can send them specific verbs if they support them, and you can even supply a value here. It could be a number, it could be a string, it could be a table. Anything that the receiving part would be able to deal with. Vars and nvars, these should look familiar because they're also part of the context table. So they're you can access them two ways. This is something that grew historically. Try to use these versions if you write your parts, because I'm thinking about removing these. So verb is something that we probably should move to CTX as well, but right now it's a global thing, and it's the verb that's being sent to your part. So usually what a respond method does, it checks for different verbs that are being supported and does different things depending on the verb that comes in. There's a context variable in the global environment. I would say don't use this if you don't have to. Use the get and set functions instead, so we can drop this in the future version. These are the two scratchpad tables or variables that are private to your parts and will remain private to your parts. My pad lives for as long as the step is alive. Trail pad lives for as long as the current request is still running, and so it will persist for an entire trail of server steps, which can really be very useful. So we're nearing the end. Now is a variable that holds the current timestamp, which is often very useful, but these days not as we actually added a now conjugate, which is actually more flexible, but this can be fairly useful. This holds the namespace, this holds the RFX string, and types is the container for any type handlers that you decide to load and use. But I'm just listing this here for completeness sake. Type handlers are a way to extend the capabilities of your part, but it's too big of a topic to discuss here, so maybe I'll do another video about type handlers sometime in the future. So, and to finish things off, the database function allows you to get a handle to the current database. You can actually provide a different, if you call it like this, it provides the database as you have modeled it for your flow, but your part can decide to open a different database by providing the name. So not the path, but the name of the database without the extension. Switch database and attach database are switch database allows you to switch to a different active database than the one that was being used. And attach database means, okay, attach the named database to the database that's already active. So you can have different databases all lumped together and use them, as if it was one database. This is actually some functionality that SQLite provides, and using the attach database functions, you can make use of that. So I didn't discuss any composer parts, but composer parts have access to these two variables, the step page and the flow page, and they can tweak that. They can override the modeled step page or the modeled flow page. But again, composer part is probably something for another topic as well. Okay, we're nearly there. Some guidelines. This is all stuff that I mentioned earlier as well. If starting small really helps. It helps you to figure things out as you go along. It helps you to test stuff as you build it. So it's not you don't start out with a really, really complex thing that you don't even know how to begin to test. So write stuff incrementally. Property names are very, very important. Why? Because parts are the building blocks. If you come up with sensible property names, other people will find it much easier to use your part, and you might even find it easier to use your part. And to be honest, my team made a lot of mistakes with property names, and we've tried to sort of fix some of them over the years, and some of them still haven't been fixed because we're always afraid of losing some backward compatibility and such. So think about consistent names. For instance, all the base parts use the class property to help you override the class that's being put on the container element. So use that because all the other parts are already using it. The same thing with associates and like the result property. Having some consistency helps. Having this sensible default values for property helps as well. So make sure you put them in, and also make sure to describe them in the info sections. Security, that's never assume what you receive is what you expect. Never forget about that. It's so easy to take shortcuts and to think that you're all done, only to find out that you've put some gaping holes into your web application. That's something that we don't want to happen, and we don't to ourselves, and I also don't want it to happen to you, because it's embarrassing. It can be inconvenient, and and it can be much, much, much worse. And as a platform, we try to protect you as much as possible. But as soon as you write your own parts, the responsibility is yours. There's only so much we can do if you blunder your way through, coding your own parts. So always be wary of whatever input you receive, and double check, triple check, quadruple check, whatever. Right, and generics. If, like I said, like I've been saying, parts, we view parts as building blocks, and we see parts as reusable components. So try and make them reusable. Try to make them as generic as possible. You know, they don't have to be generic, but if you can make them more generic, if you can make them more powerful, if you allow people to reuse them in other situations and the situation that you're dealing with right now, you know, that's usually fairly worthwhile. Finally, you know, some basic stuff. We've actually run into customers who don't check if their code actually compiles, which is, you know, the silliest thing ever. You know, if you write parts, use Lua, the Lua compiler, or use the scan script tool to ensure that, you know, it does compile and there's no silliness in there. So at least you have a fighting chance. And for debugging, you know, as I've shown you, print debug can be very useful. You know, check out the in-house setting, and well, you know, that should help. And last but not least, study all the parts that we provide. You know, the sources are available. The same holds true for the JavaScript. You know, it's a very small library. Even if you only have the minified version, you know, run it through a pretty printer somewhere online, and it's JavaScript. You already have the sources, and you have all the parts that use this JavaScript. So hey, you know, you can view them as examples of how to deal with things, and I think it'll, you know, just studying them will help you figure things out. So look at it. You know, you have the source, make use of it. Okay, so obviously there's some stuff I did not discuss. Type handlers, composer parts, improved error signaling. This is something that I should probably, you know, do a future video about. But you know, it's not important for the basics. You don't need these to come up with really worthwhile parts. And well, I hope this has been useful, and this is pretty much the overview of, you know, everything that's involved. I'm not sure if I forgot anything, but I'm sure that, you know, if anything comes up, we can address that later on. And I'd say give it a go. I'm thinking of doing a final fourth session and just look at all the information you've seen so far, and maybe run through a few of the parts that are available, and you know, highlight some of the techniques that we've discussed, and that should give you a fairly complete overview of everything you can do, and give you some pointers of how to do it. Anyways, it's been a long session. Thank you for watching. Again, I hope it's been useful, and well, until next time, bye bye.